The next case that we take is when the object is in between principal focus and center of curvature. So this is focus, this is center of curvature. Object, let's say, is somewhere here in between these two. Image location, basic principles will not change. We have already discussed, we take a ray parallel to principal axis and then make it move after reflection through the focus. So the first ray we take from the tip, after reflection we say it will pass through the focus, parallel ray. And you can also take a ray passing through focus, which after reflection will become parallel and move away from the mirror. Now where they cut is the point where the tip image will be formed and rest will be here. So the image of this is formed like this, inverted. It's real because you can take it on screen, and it is enlarged. You can see this is smaller and the image is bigger, and it's formed beyond radius of curvature. It's formed somewhere here. And finally, one interesting case we take, and which is the next case, when you say that when object is at principal focus, basic of ray diagramming will not change whichever case we take. I am repeating this again and again so that you see the logic behind making of these figures. So here is the object at focus, and we will see what happens now. Again, the point that I would like to again repeat, that principles of ray diagramming in every case remains the same. A line parallel to principal axis after reflection will pass through focus. So that you get the first ray, and then you say any line, any ray which is passing through center of curvature will strike normally and will go back on the same path. So if this ray is, let's say, coming from center of curvature, we say this like this, it strikes, it will go back on the same path. So a ray going from here on the tip will go back like this, and therefore what you'll say is that since the rays become parallel after reflection from the mirror and they are going to infinity, therefore you say image is formed at infinity. It is real because you can put a cardboard or any screen and get the image. It's obviously inverted because you see it's the tip of this will come down, this is going down, and this bottom will be here, tip will be in this direction, so it's inverted. So it's formed in front of the concave mirror, though because rays are parallel they are not meeting in real space, actually they'll meet at infinity, so you'll say that image is formed at infinity. The last case that we take is when object is in between pole and principal focus. So this will cover all the cases. So let's draw the mirror first. So here is the mirror, this is pole, focus, center of curvature, and object is between pole and principal focus, so it's somewhere here. This case is again solved using the basic principles, and that's why I keep saying remembering basic principle is the critical thing. Take the ray parallel to principal axis, and then after reflection this ray will pass through the principal focus. This we have been seeing number of times now. The other ray that you can take will be through the center of curvature, and you know that if a ray passes through center of curvature, then it strikes normally like this. I'll go back through the center of curvature like this. So the refracted ray is this, passing through the center of curvature, it strikes normally and comes back like this, which we have also studied. And other is ray which is parallel to principal axis, after reflection goes through focus. Now to find the image, you have to see where these rays meet or appear to meet. Critical point, appear to meet. They actually, if you extend this ray and then this ray, they appear to meet at this point, that is at the back of the mirror. So this tip here, arrow tip will be here, and that's why the image will be like this. So since it appears to be at the back of the mirror, naturally you cannot take it on any screen. It is illusion that you are getting. So therefore you will say it's virtual. It is erect. It is in the same way as the object is. It is erect. If it is arrow is pointing up, in this case also arrow points up, which is what we mean when we say it is erect. Image is enlarged. See the size, this is smaller and this is bigger, and it is formed behind the concave mirror. So in all these cases that we have seen, you see we have used basic properties of the mirror in locating the image. One was we took the tip, we have drawn two rays. One was parallel to the principal axis, this is the one, and after reflection it goes to the focus, this was one. In all such cases you will see the same thing. So whether it's this case, parallel to principal axis going back like this after reflection, parallel to principal axis going back like this after reflection, ray 1, again parallel to principal axis going through focus. So this is one ray that is present everywhere, parallel to principal axis passing through focus, and parallel to principal axis passing through focus. And the second ray we have taken again by the logic, which is, for instance, if a ray passes through center of curvature, it will go back on the same path. So ray comes here, this is the second ray, it goes on the same path. We show it just a single line. Same thing we have done here. In this case, though we have not taken ray passing through center of curvature in these two, this is here in this case. In this case we have taken one more ray parallel to principal axis and going through focus to locate the image. This also you can do in different situations. All three rays are valid. Similarly here you have taken a ray passing through focus and becomes parallel to principal axis. Here again we have taken a ray which is going through center of curvature and going on the same path. So the three types of rays which you have used, one is we have used the property of parallel to principal axis and then it goes through the focus, or going through the focus incident ray and then becoming parallel, or third going through center of curvature and coming back on that line itself. So these are three properties which, when combined with actually laws of reflection, I incident angle is equal to reflected angle with a normal, and all three lie in the same plane, gave all the cases that we have discussed. It is very, very important for you to understand the logic and not cram, otherwise the whole thing will become very troublesome. understand the logic that I have given, and this will help you all throughout.